Hello and welcome back to Physics Safari. My name is Abhishek and this is the second lesson on the projectile motion. In the previous video lesson, I have discussed about the time period, range and the height of the projectile and essential things about the projectile. I am sure you must have gone through the previous videos. If not, you must go through that before you watch today's lesson. Today's lesson is going to be all about the trajectory of the projectile. All good? So I'm going to provide the link of the previous video in the description box as well as in the I button. You make sure watch that video before you come to this one. All good? Okay. So let us start. So before I start, let's have a quick recap of what we have done in the previous video. In the previous video lesson, we have seen that when a projectile is projected at an angle, let's suppose theta with the horizontal, with initial velocity of u, then it will take a parabolic path and it will come back to the, let's suppose, the ground. Today we are going to discuss about this path. Now, in the previous video lesson, we have seen that we had u sine theta as the vertical velocity and u cos theta as the horizontal velocity. U cos theta as the horizontal velocity. Range of the projectile was given as u square sine 2 theta upon g. Height of the projectile was given as u square sine square theta upon 2g, and the time period of the entire flight was given as 2u sine theta upon g. 2u sine theta upon g. And let us take this discussion further, and today we are going to talk about this path which the body takes or which the projectile takes. This path is called the trajectory of the projectile. Now, what makes it so important? Let's say, for example, at a certain instant of time, I want to find the position of the object, the position of the projectile. Let's suppose at this particular time, at any time when its horizontal range, horizontal position, let's suppose x and let's suppose this is y, is over here. Corresponding to this is going to be your y coordinate or the height of the projectile. So if I could locate the projectile, that would be very, very important, and that's going to be helpful in various ways. Later on, going further, we're going to see a lot of questions in which the position would become very important, especially in the JEE mains question. Now, so relating the y position and the x position is called the trajectory of the projectile. Now, quickly what we can do is, we knew that at any point of time, the x would be given as how much? The x position, let me write here, the x position would be given as how much? U cos theta into the time t, at any time t, that is going to be the x coordinate of the body. At the same time, the y coordinate should be given as how much? Y, ut minus half gt square. Well, u is going to be how much? U sine theta t minus half gt square, half gt square. So that is the x and this is the y coordinates of the body. So trajectory is basically all about the variation of the y with respect to x. All good? So with respect to certain x, what's going to be the value of y? That could be easily depicted from the trajectory of the projectile. What essentially we're going to do is we're going to remove the t because I do not want t in the relation of x and y. So from 1, can I say t is going to be x upon u cos theta. Let us substitute this in this second equation of y. So y should be how much? U sine theta. T is going to be x upon u cos of theta. Negative, here we'll be having what? 1 upon 2 g. T already we know it's x upon u cos theta. So x upon u cos theta whole square. Let us simplify this. U should be cancelled. Sin theta upon cos theta is going to be tan theta. So y is going to be x tan of theta negative. You'll be having what? G x square upon 2 u square cos square theta. And this is the equation of trajectory. It is very, very important. If I ask you guys at night 2 p.m. also, 2 a.m. sorry, you should be having this in your mind. Do not forget it. If you need to write it for multiple times to memorize it, do not hesitate in doing that. Now, how it can be useful to you? How it's going to be useful to you? Let's say that if I have an object, if I have a projectile which is following, let's suppose this path, y is equals to, let's suppose, maybe you can say 3x, y is equals to 3x minus 2ax square. If any projectile is following this trajectory, and if it is given, I can actually find the value of u. Of course, we can find the value of u over from here, isn't it? You know, u and theta could also be found from here. Both could be found. How? Let us do the comparison of this and this one. Let us do the comparison of this one and this one. If I do that, I could say that tan theta should be equals to how much? Tan theta should be equals to 3. Tan theta should be equals to 3. Also, if you look at this one, that will tell you that g upon 2u square cos square theta is going to be how much? 2. Well, from here I can get the value of theta. Theta should be equals to tan inverse of 3. G value is known to you. Theta value we have got from here. U value we can find from here. So this is going to be helpful to you if we given the trajectory of any path, any projectile, we can do the comparison, we can find the initial velocity, and also we can find the angle of projection quite easily from here, isn't it? Now you might be thinking how to convert this tan to cos, so easily we can do that. That's not going to be a big deal, isn't it? But yeah, ठीक है जी. Now let's say what else can we do with this trajectory? Can we do some manipulation with this trajectory to get it into the different form? Yes, of course we can do. In fact, we can write this trajectory in one more format, and we can also apply some constraint which is going to be helpful in a lot of questions for you. So let us see what are the manipulations that we can do with this trajectory equation. Okay, for that I'm going to erase this part. Okay, isko hatate hain. Let's remove this. Also, let's make this part free so we can get slightly more space to write. All right. Okay. So now let's say just now we have seen that the equation of trajectory says y is equals to x tan of theta minus g x square upon 2u square cos square theta. Now let us take x tan theta common from here. If I take x tan theta common, then I should be having 1 minus, say this one is going to be how much? Gx upon, simply write 2u square cos square theta. Since this tan theta I do not want here, so it should be having how much? Into tan of, okay, it should be in denominator, my bad. It should be tan theta. Now if you open this up, you will be getting how much? G x square upon 2u square cos square. Tan theta would get cancelled, so here we have. Okay, going further, this could be written as x of tan theta. Let's try and simplify this one. So it's going to be g of x, like gx cos theta. Sin is what? Tan is what? Sin upon cos. One cos would be cancelled. So let me write for you. Let me write that as well for you. This is going to be sin theta upon the cos of theta. Now this will be cancelled. Now what we have? 2 sin theta cos theta should be sin 2 theta. So this is going to give you x tan of theta 1 minus, well, we can have, okay, let me first write just x over here. And here we can have what? 2 sin theta cos theta would be sin 2 theta. Here we have u square. If I get this g in the denominator, see, this is nothing but the range. U square sin 2 theta upon g is the range of the flight. So this could be further written as, the y could be written as x tan of theta times 1 minus x upon r. So this is the second format of the trajectory of the projectile. There are going to be quite some questions in which this would be easily and directly used. So I believe you guys have understood this. Note it down, please. Pause the video, note this down, and then we're going to move ahead of it. All good? Very good. So if the range of the flight is given and the angle of projection is given, we can actually find the y coordinate with this formula directly. We do not have to do any such things other than this, है ना? चलो, now what next we can do is, can we put some more constraint on this projectile motion or not? Let's say, can we put some more constraint or not? Okay, so here we have. Now, can we just write this as in terms of tan of theta? इसमें, or can we just make sure that can we just write this in terms of tan theta or not? है ना? तो एक काम करते हैं. This could be written as what? Y is equals to x tan theta, as it is x tan theta negative gx square upon 2u square, gx square upon 2u square. This cos square theta when taken upward, that is going to be what? Sec square theta. Now, why am I doing that? Because I know that sec square theta could be written as 1 plus tan square theta. Huh? Now, already we have tan theta over here. So, I also wanted to get a tan theta over here in order to make a quadratic format. All good? So, what we can do is y could be written as x tan of theta negative gx square upon 2u square. Sec theta could be written as 1 plus tan square theta. 1 plus tan square theta. Okay, looking at this, I can actually get a quadratic in the terms of tan theta. From here, I can get the quadratic in terms of tan theta. Let's do that. Let's do that. So this y, okay, let me come this side for it could be visible to you people. While I'm writing x tan theta negative, I can say gx square upon 2u square. All good? And here we have what? Negative gx square upon 2u square tan square theta. Energy. Let's try to make it a quadratic in tan theta. Get the constant together. So this is, and this one could be a constant taken as a constant. So can you just see that gx square upon 2u square tan square theta and minus x tan of theta plus y minus gx square. Okay, even this is going to be plus gx square upon 2u square. See this. So we finally have got a quadratic in tan theta. We have finally got the quadratic in tan theta. Anyone? Any doubt with this? Okay. So this is what we have, a quadratic in the terms of tan theta. Now, I know that theta is a real value. Theta is a real value over here. Correct? So for the real value, the discriminant should be more than 0, or equals to 0, you can say. Now, so b should be how much? B square. What is b? X. So b square minus 4ac. 4. A is how much? A is this part. This is your A. So gx square upon 2u square. B square minus 4ac. What is c? C is going to be y plus gx square upon 2u square. That should be more than 0, let's say. Now, I think we can cancel it. We can cancel it. Let us take out x square common from here. So, x square 1 minus 2g upon u square. This is going to be how much? Y plus gx square upon 2u square, and we can put a curly bracket. That should be more than 0. X square is a positive quantity. It means this, and a positive quantity, something multiplied, going to give you more than 0. So even this should be more than 0. Even this should be more than 0 because that cannot be negative for sure. This could be positive. Hona hi hona hai. Okay. So what I'm going to get from here is 1 negative 2g upon u square y plus gx square upon 2u square should be more than 0. That means if I take it that side, I should be having 1 is more than 2g upon u square y plus gx square upon 2u square. It's a very important result. I'm going to use this in some questions going forward in the later part of the session. So I'm sure you guys must have noted it down. So 1 should be more than 2g upon u square times y plus gx square upon 2u square. ठीक है जी. So this is what we can do. These are the three manipulations on the trajectory of the projectile, and all three should be known to you. The first one is y is equals to x tan theta minus gx square upon 2u square cos square theta. Second one that we have seen just now, that y is equals to x tan theta times 1 minus x upon r. So this is used when we have the range. Now this is a condition, which we use in a few questions in a good level question. तो ठीक है, इसको हम लोग बाद में use करेंगे. So now we have seen the different trajectories equations. We also going to see the use of that, है ना. इसका हम लोग बाद में use भी देखेंगे जी. और चाहो तो इसको थोड़ा और सिंप्लीफाई कर सकते हो. इट्स कंप्लीटली अपॉन यू. इसको चाहो तो यू कैन सिंप्लीफाई दैट. यू टेक दिस यू स्क्वायर दैट साइड. यू स्क्वायर शुड ऑलवेज बी मोर देन योर maybe you can say that u square upon 2g. कर लो, लिख लो कोई दिक्कत नहीं. So from here what you can say that u square upon 2g should be more than y plus gx square upon 2u square. You can remember in any of the formats. Okay. Okay. So what I was saying that when you throw the object, like this, it goes up and come back. If I talk about the kinetic energy, of the projectile, a simple question to you: is kinetic energy 0 at maximum height? Yes or no? At the topmost position, does the kinetic energy become 0? Does it become 0? Answer is no. The reason being, at the top point also it will be having some velocity, that is going to be u cos theta, right? So one thing you need to understand, the kinetic energy never becomes 0. Yes, it will decrease for sure, because the velocity will first decrease till here and then it will increase. So you can note down one thing: velocity first decreases and then increases. Kinetic energy can never be 0 during the entire motion of the projectile. It will not be 0. Yeah, of course it will decrease and then it will increase. ऐसा हो सकता है, but वो 0 नहीं होगा. Now, so far we have seen about the projection of the body from the ground. We can have various projection also. We can project it from a certain height. हम लोग इसको certain height से project कर सकते हैं. So broadly we have 3 different types of projection possible in this entire stuff. First one is ground to ground. Second one could be like this. It could be projected from all certain height. So थोड़ा इसको और let me put it down. So let's suppose it can be projected from a certain height. Now, when I'm projecting it from certain height, let's suppose that height is h already. Again, from here the projection could be given in 2 formats. We can have the projection in two different formats. One, it is thrown at a certain angle from here, making some angle, so it will go like this, and it will somewhat come like this. The second way of projecting the object from a certain height is like this. It could be projected downward. So let's suppose this height is h. This is the height h. It could be projected downward, ऐसे. It could be projected downward. Let's suppose making some angle theta with the horizontal. So this body will go like this. So these are the 3 different ways of projection. But the rules will be same in all the cases. Over here, this is going to be the range. Here, this is going to be the range. That's not going to change. The range will be still the same as the horizontal movement of the body from the point of projection, till where it lands. Also, I want to tell you something, that the time in which the body, let's suppose it is thrown with a certain velocity u, and also we can have one more projection. And that should be like this. If it is thrown from a certain height, it could be just projected horizontally, making 0 degree with the horizontal. So this is going to go like this. It will go tick, 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 and this will come on the ground. So these are the 3 possible ways of projection, including this, the 4. Now, you need to understand one thing. The time in which the body came from this point to this point, that is the time in which it has moved a certain horizontal distance, In the same time, the body has traveled a vertical displacement as well of, let's suppose, h. So the time for this movement and time for this movement is same. So what we're going to do is, in the next video, I'm going to do a lot of questions. That video is going to be slightly of the longer length also. I'm going to show you how we can find the time from this or with this given informations, and we can use in the either of these. And the same case is going to be true for all these cases. Let's say for this one. Let's say for this one. What is the height? It has moved minus h, because net final displacement is minus h over here. When the body comes over here, the final displacement is minus of h. U is going to be how much? If I talk about the vertical, u should be, if it is u, this is going to be how much? U sine theta, and this is going to be your u cos of theta. Well, this is in the vertical upward. It means that should be positive. So क्या हो जाएगा जी? It is going to be u sine theta t ut minus half of g times of t square. You will be getting the quadratic in t. Okay. You will get the two values of t, a positive and the negative. Neglect the negative one because time cannot be negative, and choose the positive one. That's the way of doing over the question over here. And this is going to be true in all these cases. This is going to be true in all these cases. इसको देख लो जी. Initially, what is the horizontal velocity? U. What is the vertical velocity? Is 0. So in this case, h will be how much? Negative h equals to u2 is 0 minus half of gt square. So h will be half gt square. So this is the easiest among all these three. Of course, even these are also easy. But since because the vertical velocity, vertical component of the velocity becomes 0, it becomes slightly easy for the calculations. And we have always looking for the things in which the initial velocity becomes 0. That makes it more easy for you for the calculations. Likewise, in this case, your velocities component along the vertical should be u sine theta, that is going to be downward, and here we can have u cos of theta, which is horizontally towards the right hand side. H of course negative, so equation should be minus h is equals to u will be negative downwards, so minus u sine of theta t minus half gt square. So essentially all the negatives would be cancelled. We'll be having h equals to u sine theta times of t plus half of gt square. Again, you solve the quadratic equation. You will be getting the two values of t, one going to be positive, another going to be negative. Neglect the negative because time cannot be negative. Already we had discussed it multiple times. All good? And then you can get the value of, take the positive value of t. That should be your answer. All good? ठीक है जी. Now, couple of more things I would like to discuss before I wrap up today's lesson. Post that, we're going to do in the next class. We'll do quite a good number of numericals. And we're going to talk about the inclined projectile going forward. अच्छा जी, एक बात और आपको बताते हैं. So let's suppose if I have the projectile, चलो let me make some more space. If I have a projectile being thrown from the ground, being projected from the ground level. And you must have noticed while writing this equation, the point of the projection is taken at the origin. That's a point of the projection where we take the origin. This is the origin for you. All good. That's the reason why we get the negative displacement, because this becomes your point of origin where the body is projected from. Keep that in mind. That's going to make it easy for you to understand. थोड़ा आगे बढ़ते हैं. So let's suppose if I have a projection like this. Okay. Now at any time t, let's suppose the body's position is here. It is here. Okay. Now this is going to be your displacement. This is going to be your vertical, and this is going to be your horizontal movement. And this length, let's suppose this is O, A, B, then this is your displacement. This is your displacement. Of course, this curved path would be the distance, no doubt about that. But the displacement is going to be this one only, you know. भैया आपका हो जाएगा displacement. ठीक है ना जी? Okay, this part is also coming over here. कोई बात नहीं. Now, if I want to write the position vector of this at this point, let's suppose I want to write the position vector of the particle at point B. Then I can say that what? I can say, okay, चलिए इधर लिखते हैं. RT at any, the position vector of the point as a function of time t, you can write position vector as a function of time t. Position vector as function of time t. Is a function of time. Position vector is a function of time. So RT should be given as what? This is x. This should be how much? Ux into t. That should be ux times of t. I cap plus vertical. So vertical should be how much? Let's suppose this is y. You can write this as y and simple j cap. Because this is having there is no acceleration in the horizontal direction. So easily we can write ux times t. But in this case we have the acceleration. So for that we have to write the equation properly. So here we have RT should be given as uxt. Let it be uxt. Y should be how much? This height h is equals to ut plus half gt, minus half gt square. So uy t minus half g t square j cap. So this is how you can write the position vector as a function of time t. Now if I have the position vector, definitely I can find the velocity vector. Let us differentiate this. So if I differentiate this, so that would be giving you what? drt upon dt should be nothing but your velocity as a function of time t. Now in this case it should be how much? Ux plus u times of y, t derivative is gone, minus 2gt upon 2, so 2 would be cancelled, gt upon j cap. So this is your velocity vector as a function of time t. Now if I want to find a displacement or I want to find a distance, that's not a big deal. So you can write that. So distance is going to be your velocity vector magnitude dt. Take the integration. We have discussed this already in the kinematics. And your displacement should be how much? Your displacement should be equals to just v dt, and you can put the limit 0 to any point of time t, 0 to any point of time t. So these are the ways in which we can find. Now if I want to find the displacement also, from here if I look at this this diagram, the displacement should be how much? The displacement should be using the how much? Using this triangle, you can say x square plus y square. Now what is x? Uxt. What is y? This one. So let me use this space itself. So displacement could also be written as under root of ux t whole square plus this part, which is nothing but uy times of t minus 1 upon 2 gt square whole square. So this is going to be your net displacement. This should be your net displacement. So yeah, that's all. If you know the trajectory properly, if you know all the formulas of trajectory, if you understand the position vector of the this projectile, which could be written as a function of time t, then you will not be finding any difficulties in solving the questions, because what they will ask you, they will ask you to find the value of displacement, distance, position within time t, velocity, jo bhi puche, whatever they ask, we can do that. There are going to be a lot of questions that, okay, there's a sort of plane flying and we have to hit that, monkey is falling, we have to hit that. There are going to be so many questions coming up here. So don't you worry. What I've done so far, what I've discussed so far, make sure you do grasp them. If you need to watch the videos multiple times, do not hesitate. I would just say that. Okay, but you do make the notes properly. Each and everything should be noted down properly. Understand them. If you have some doubts, do let me know in the comment box.